Think of the ER model as a blueprint for your database. Just like a house needs a plan before construction, a database needs structure before coding. It visually maps out the key data, their properties, and how they connect, making sure nothing important is missed. The ER model helps everyone involved, designers, developers, and business owners, speak the same language about data. By planning with an ER model, we catch problems early and avoid costly fixes later. For example, in a school, the main entities might be students, teachers, and courses. In a library, books, members, and loans. The ER model helps us identify these core components and define their relationships. It translates real-world scenarios, like a student enrolling in a course, into a structure a computer can manage. This process ensures our database is logical, efficient, and matches the needs of the organization. Starting with a clear ER model sets the stage for a successful database project. It's the roadmap guiding every step from concept to implementation. Every ER model is built from three core elements: entities, attributes, and relationships. Entities are the main objects or concepts. Think student, teacher, or course in a school database. Attributes describe these entities, like student ID or date of birth for a student. Relationships connect entities, showing how they interact, such as a student enrolling in a course. For example, in a library, entities might be book and member, with a relationship called borrows. Attributes give details, like ISBN for a book, while relationships answer questions like, which books has a member borrowed? Identifying these three elements lets us map out the data landscape clearly. Entities define what we track, attributes describe them, and relationships show their connections. This framework organizes complex information into a logical structure. Mastering these basics is the first step to effective database design. With these building blocks, we can model any system's data. To bring an ER model to life, we use an entity relationship diagram, or ERD. ERDs use simple shapes, rectangles for entities, ovals for attributes, and diamonds for relationships. For example, a student entity is a rectangle labeled student, with ovals for attributes like student ID and name. Relationships, like enrolls in, are diamonds connecting entities such as student and course. This visual language makes it easy to see how data fits together at a glance. Connecting ovals to rectangles shows which attributes belong to which entity. Diamonds between rectangles clarify how entities interact. These standard symbols keep diagrams organized and easy to read. An ERD is more than a drawing, it's a precise map for building the database. With this clarity, everyone on the team can understand and discuss the design. Not all attributes are created equal. Understanding their types is key to a strong ER model. Attributes can be required, like student ID, or optional, like phone number. Simple attributes can't be broken down further, while composite attributes, like address, can be split into street, city, and zip code. Some attributes are single-valued, one date of birth per person, while others are multi-valued, multiple phone numbers. In ERDs, multi-valued attributes are shown with double-lined ovals. The most important attribute is the identifier, or primary key. It uniquely identifies each entity instance. For students, that's student ID. For books, it's ISBN. Identifiers are underlined in diagrams to stand out. These distinctions help us design databases that are accurate and efficient. Choosing the right attributes and identifiers ensures we can always find and distinguish every record. This attention to detail prevents confusion and keeps our data reliable. By classifying attributes carefully, we build a solid foundation for the entire database. It's the difference between a messy system and one that works seamlessly. Relationships define how entities interact, and they come in three main types: one-to-one. Each instance of one entity matches exactly one of another, like a country and its capital city. One-to-many. One entity links to many others, but each of those links back to only one. Think customer and orders. Many-to-many. Many instances of one entity connect to many of another, like students and courses. These types shape how data is organized and accessed. One-to-one relationships are rare, but useful for tightly linked data. One-to-many is the backbone of most databases, handling things like customers and their orders. Many-to-many relationships require an extra table to manage the connections, but they're essential for real-world scenarios. Getting relationship types right ensures the database reflects business rules accurately. It also prevents data errors and confusion down the line. Understanding these types is crucial for building robust, flexible systems. They're the glue that holds the data model together. Beyond basic relationships, we use constraints to define exactly how entities connect. Cardinality specifies the minimum and maximum number of times an entity can participate in a relationship. For example, a customer can place 0 or many orders, but each order must belong to one customer. These rules are shown on ER diagrams with notations like 0, n, or 1, 1. Existence dependency is another key concept. Some entities can't exist without others. Strong entities stand alone, like students or courses. Weak entities depend on strong ones, like a dependent needing an employee. Weak entities use part of the strong entity's identifier as their own. In diagrams, weak entities have double-lined rectangles, and their identifying relationships use double-lined diamonds. These constraints keep the database logical and consistent. They enforce business rules and prevent invalid data. By defining cardinality and dependencies, we ensure the model matches real-world needs. This attention to detail is what makes a database reliable. Let's build a simple ER diagram for a library system. First, identify the main entities: book, member, and loan. Draw rectangles for each. These are your building blocks. Next, add attributes: ISBN, title, and author for book, member ID, name and email for member, loan date and due date for loan. Underline ISBN and member ID as primary keys. Now, define relationships. A member borrows books through loans. Each member can have many loans and each loan is for one book. Draw lines to show these one-to-many relationships. Add cardinality. A member can have 0 or many loans. Each loan must belong to one member. For books, a book can be loaned many times, but each loan is for one book. Review and refine the diagram to ensure it matches how the library works. This step-by-step process turns real-world needs into a clear, accurate data model. With practice, building ER diagrams becomes second nature. ER modeling isn't always straightforward. Designers face real challenges. Ambiguous business rules can cause confusion, so asking the right questions is crucial. Deciding how much detail to include is a balancing act. Too simple, and you miss key data. Too complex, and the model becomes hard to use. For example, should address be a single field or split into street, city, and state? It depends on how the data will be used. Sometimes, practical compromises are needed. Performance or system limitations may require denormalizing data. Not all database systems support every ER feature, so the model must adapt to technical constraints. Translating the ER model into a working database can introduce new challenges. The designer must ensure the final system matches both the model and the real-world needs. Overcoming these hurdles is part of the art of database design. Flexibility and clear communication are key to success. The best ER models are both practical and precise. They lay the groundwork for reliable, efficient databases. The ER model is the foundation of good database design. It breaks down complex systems into clear visual components everyone can understand. This shared understanding helps avoid costly mistakes and ensures the database meets real needs. A well-designed ERD leads to efficient, reliable, and consistent data. It guides development, supports future updates, and serves as documentation. When requirements change, the ERD can be updated, keeping the database aligned with business goals. Mastering ER modeling is essential for anyone working with data. It's about translating real-world complexity into a logical structure. With a solid ER model, your data becomes a powerful asset.